All right, for the last video, for 3.3, we're going to solve a problem where we have a baseball and it's being hit by a batter, where y is height in feet and t are the seconds after it is hit, can be modeled by the equation that is given to us. So negative 16t squared plus 80t plus 4. All right, so let's I'm a very visual person, and I do find it easiest if I actually draw what's being talked about. All right, so we're going to say this is baseball. All right, I'll draw my little batter. Obviously, this is not to scale. Here he's holding a bat. And he hits this ball. It's going to go up, and it's eventually going to come down and hit the ground. Okay? All right. So that's what's happening. That's what this equation is showing this curve. This plus 4 means he is hitting that ball 4 feet off the ground. So if this is my y-axis here, that's 4 feet off the ground. That's what that meant. Okay? Got a lot going on there. All right, so we want to find the maximum height of the ball. So we want to find the max of my parabola, which is the y value of the vertex. Okay? So we can do this a couple of ways. We learned how to find the x value by taking a negative b over 2a, and then we can plug it in and we can find y. You can graph it and you can find your max height, but we might end up needing our x value anyways. So let's go ahead. In previous problems, we learned how to write this in vertex form. So let's do that. Let's take our y over here. We're going to add some number to it. It's going to equal negative 16t squared, I want to put that in parentheses, sorry, plus 80t plus some number, and then I still have that plus 4 on the end. All right, let's make this a perfect square trinomial inside that parentheses. The only problem is I have that 16. I can't have that 16 there. So we're going to divide both of these terms by 16, and I end up getting t squared minus 5t plus some number. Now it's plus 4. Okay? And then this other side is still, we don't know what that number is we're adding. So we take that 5, we half it, and we square it. So we half 5 halves, and I get, 5 halves. I'm sorry. We half 5, and we get 5 halves. Whew, got my words mixed up. And then I square that, and I end up getting 25 over 4. Now, I can't just multiply that or add that to the other side. Oops, I wrote it in the wrong thing. I wanted over here. I can't just add 25 over 4 over here. That doesn't work because I have this negative 16 out here. So I'm going to take that negative 16 and I'm going to multiply 25 over 4 because that's what it means being out here. It needs to multiply. So I'm going to multiply it by 25 over 4 times negative 16, and I actually get a negative 100. Okay, so those are still the same number. It's just this number on this side is being multiplied by negative 16. Okay, so now let's rewrite this. So I have y, plus a negative 100, same thing as saying minus 100. It's negative 16. Let's write this as a binomial. So t squared minus, and half of b would be negative 5 over 2 squared. And then on the outside, I still have a plus 4. Okay, we need to add 100 to both sides. So I'm going to get y equals a negative 16 t squared minus 5 halves squared. None of that changed, but here I have to do that combination there, so I get plus 104. So there's my equation in vertex form, which our max height is always the k, the number on the end, so I know my maximum height is 104 feet. Okay, this is max height. All right, and then B says, how long does it take this ball to hit the ground? That's why I went ahead and did this, did that part, basically the completing the square part, because in B, we now want to say it's going to hit the ground, which is when y is 0, because remember, we had our x-axis here. That ball, that y-intercept was at 4, but where the ground and that meet is 0 is when x and y are 0. So If I want this, that is when I'm on that x-axis, so y is 0. So I'm going to plug in 0 into my equation. Just leave everything else the same. And then I'm going to solve. So I've got to subtract 104 to both sides. So I get negative 104 equals negative 16 times t squared minus 5 halves squared. Oh, whoa. I just realized I'm writing t squared in way too many places. I apologize. Oops. And me deleting it's going to make a mess. Sorry, this is just t. Goodness. This is just t minus. It's not t squared inside. Oh, I did it all the way up. Not all the way up, but I did it up here too. So ignore, my goodness, ignore that one too. That one's not there. I'm sorry, I'm human and it's showing. Okay, so now I need to be able to solve this by square roots, so I need to divide by the negative 16. Okay, so I end up with 13 over 2. That's how it simplifies on that left side, and it's going to equal t minus 5 halves squared. Square root both sides, and I'm going to move it over here. This side becomes t minus 5 halves. The other side becomes plus or minus the square root of 13 over 2. Now, because I know I'm moving off to the right and not to the left, the ball went forward, I'm going to ignore the minus in this problem, okay? Because this isn't just a parabola, this is actually a problem where a ball is being thrown, okay? I'm not counting it going backwards to the ground, okay? He hit the ball, so it had to go forward. So I'm going to ignore the minus. So I have t minus 5 halves equals the square root of 13 over 2. And then I need to add 5 halves to both sides. So it's going to be t equals 5 halves plus the square root of 13 over 2. You cannot combine those. It is, oops, that's all square root. It is not 5 halves times square root of 13 over 2. And then I'm going to plug this in my calculator and round, and I get about 5.1 seconds. If I can write, I can't write. Okay, seconds. Or if it wants a whole number, it'd be 5 seconds. All right, so go to your practice and do number 63, turn in your assignment into big ideas, and then submit your screenshot of your score into Canvas.